Okay, geometries, this is Mr. Bloom, and this is geometry lesson 4.4 using corresponding parts of congruent triangles. Our objective today, students will be able to use triangle congruence and corresponding parts of triangles to prove that parts of two triangles are congruent. Wow, that's a lot of stuff. We are going to make sure that we recognize that once we prove triangles are congruent, the parts of the triangles we did not use in that proof are congruent, and we can use them to prove other things. So let's see how this works today. So first of all, essential understanding. If you know two triangles are congruent, then you know that every pair of their corresponding parts is also congruent. All 6 pieces are congruent to each other. Remember that. So if we can bring this down, we can talk about this next problem. Is triangle ABC congruent to triangle GHI? And how do you know? Why don't you look it over, turn it off, look it over, and kind of work through a formulation for yourself. Okay, welcome back. Now, if I'm looking at my first triangle here, ABC, I'm looking at this idea that ABC is marked with a double marking a single. This has got a single and a double. So if I can add these two together to find my angle E. So I got 62 and 38, that's 100. So I subtract a 100 from 180 and I get that angle E is 80. Well, if this is 80 and this is 80 and my markings is as, I know by side angle side that triangle ABC and triangle DEF are congruent. Okay, and that's by side angle side. Now, if I go further here and I look at the triangle DEF and I consider the fact that I have 80 and 38, and remember, I now know that angle E is 80 degrees. I now have angle side to prove triangle DEF congruent to triangle GHI. So now I've got DEF and GHI congruent. Now, if you recall, since ABC is congruent to DEF and DEF is congruent to triangle GHI, I now know by transitive property that triangle ABC and triangle GHI are congruent as well. So we are able to prove that they're congruent, and that's how we know it. Now, proving parts of triangles congruent. Proving parts of triangles congruent. We've got a given, and every time you look at a given, make sure you kind of orient yourself. KBC, I got angle KBC marked. I've got angle ACB, that's marked. So these two are marked. Then I got angle K and A. Angle K and A are also congruent. They want us to prove this congruent to each other. Well, in order to do that, we are going to prove triangle CBK congruent to triangle BCA. And then after we prove that, using corresponding parts of congruent triangles, we can prove that the pieces of two congruent triangles are congruent. So how is that going to do? First, well, we're going to prove those two triangles congruent. So we got triangle ABC and triangle KCB we're going to prove. But the first thing with every proof is to write down the given. What I've done here is I've jumbled the steps, okay, the statements and reasons, and you just got to search through and find our given. So we find the given. Okay, we've got our given there. Now, remember, I'm going to give you a hint on this. I want you to prove a triangle congruent to another triangle. And right now we have two angles and we have a reflexive property. So if I consider reflexive property here, CB and BC, I'm going to look down here. Oh, we got that right here. And I've got reflexive property of congruence. That's how I know I can talk about it that way. And now our next thing is, we have the two triangles congruent because I have angle side for my congruence. So I've got my triangles congruent from angle side congruence. And after I get that done, my next step is to know that if I've got two triangles that are congruent and they both have KB in them and AC, So I know KB and AC are going to be congruent because they're corresponding parts of two congruent triangles. And that's our finish for our proof. So basically, the new thing today from learning about side, 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 angle, angle, and angle, angle, side is corresponding parts of congruent triangles are congruent. That's our new thing today. Other than that, everything's just like we are working in section 4.2 and 4.3. Now let's go on to our next proof here. Okay, got another one, and I've broken it down the same way. Okay, now I've got the given segment BA. Let's get this whole thing in the picture here. Oh, there it is. I got my given, I got segment BA. Segment BA congruent segment DA. And BA and DA are marked. CA and EA are marked. Well, I'm looking at these two triangles. If I'm going to prove these two triangles, I've got vertical angles because here. So I got the two triangles congruent. And after I prove those two triangles congruent, I can say that corresponding parts, angle C and angle E, are congruent by corresponding parts of congruent triangles. So if that's how I'm going to do it, I'm going to have you step through it because we just did the 20-second ticker. So you go ahead and use the hints I have here and write your proof. Turn me off and write it. Okay, welcome back. The first thing you should have had was your given. Okay, next thing, we had vertical angles. And then after that, we have our triangles congruent because of side, angle, side. Now keep in mind, once we are able to say vertical angles, we should have marked our triangle, and then we had side, angle, side, side, a side, an angle, and a side, and a side, an angle, a side in each. And then once we do that, corresponding parts of congruent triangles are congruent, and that's our last step for this proof. I hope it's starting to feel like you're getting it, and if you're not, make sure you talk to your local geometry teacher. Again, our next proof. Okay, now let's see if we can get this whole thing on there. Well, I got the given at the bottom, and it's not like a secret. The first thing we got to go is given. So let's talk about putting our given in, okay? And I'll be able to close things down a little bit so we can see everything in the proof and the picture and all. So we'll see how that is. Now, let's talk about this. I've got a given of A is parallel, AB, segment AB is parallel to segment CD, segment BC is parallel to segment DA. Now, on this particular diagram, I don't have any of those things marked. So we're going to mark them, okay, this way. And these double-headed arrows mean that BC is parallel to DA. The single-headed arrows mean that AB and CD are parallel. Now, keep in mind, we're supposed to prove segment AB congruent to segment CD. That's AB is congruent to CD. Now, in order for us to go about this, we first must prove this triangle congruent to this triangle. And how we will do that is, first of all, when you're given parallel lines, you got to be thinking about alternate interior angles or corresponding angles, angle pair relationship set of angles, probably alternate interiors. But let's talk about which ones we're looking at here. If I'm looking at alternate interiors, I've got this one and this one, and I've got this one and this one. Those are the two sets of angles we're going to be looking at. And then we have a reflexive property. And our reflexive property, we'll mark that in black. And this right here should be congruent to itself. So we have alternate interior angles, and we have reflexive property, and we'll be able to prove the two triangles by angle, side, angle. And after we prove the triangles congruent, remember, after we prove the triangles congruent, we can use corresponding parts of congruent triangles. Turn me off and go ahead and organize that proof. Okay, welcome back. Okay, we had our given, and depending on how you wanted to go about it, there's a couple things. Some people like to do the reflexive first because it's the easiest step, and then they go to the given and talk about their angles. So I had angle CBD, CBD, and ADB, okay, from alternate interior angles. I also have ABD and CDB, again, because of alternate interior angles. And then we have our triangles, congruent, because of angle side angle. And then because the triangles are congruent, I grabbed the wrong thing. Because our triangles are congruent, we know that there are corresponding parts in those congruent triangles congruent, and that's how we know segment AB is congruent to segment CD because the corresponding parts of congruent triangles. Okay, we're done with this one. Let's see if we've got anything below, and we'll go on to our next proof. Now, I'm hoping that you're feeling confident with these and it's starting to take off here. Again, this one is a little bit smaller than what I'd planned. Let's see what we can do about that. Okay, but let's look at the given, and well, let's just write our given down. We got AB, so I got segment AB here, and I got my given provided. Okay, now we'll be able to fit that in our screen here. We'll bring this up a little bit so we have some room. Now, as we're looking this over, I have AB congruent to AC. AB, okay, these are marked. And M is the midpoint of BC. So M's the midpoint. We got to say something about this, but I know this is true. So let's talk about that first. I know that BM and CM are congruent because of the definition of midpoint. Then I also know AM is congruent to itself because of reflexive property. And once I do that, I have these two triangles congruent because of side, side, side. And then the parts of those two congruent triangles are congruent as well by CP, CTC. We have to prove the triangle is congruent before we can use corresponding parts of congruent triangles are congruent. So turn me off, go ahead and write the proof. Okay, let's check how you did. Now, I've got my next thing, I've got reflexive property. Okay, AM is congruent to AM, segment AM. My next thing is to use my M as the midpoint of BC. M is the midpoint of BC. I know by definition of midpoint that BM, segment BM is congruent to segment CM. Okay. Now, right now, I have three sides of one triangle congruent to three sides of another. Okay, so I have the two triangles congruent because of side, side, side. Let's try to get these lined up better. And now, after I prove the triangle is congruent, I know the corresponding parts, triangle AMB, congruent to triangle AMC, by corresponding parts from congruent triangles are congruent. Okay, so this seems to be going pretty well so far, we hope. Okay, let's go on to our next one here. And we got two left. Okay, so we have two left here. A is the midpoint of MT and A is the midpoint of SR. So A is our midpoint of MT and SR. Okay, so I've got to say some stuff about MA being congruent to TA and SA being congruent to RA because of the definition of midpoint. Then because it's in a bow tie look, I know I got vertical angles of Sam and Rat to deal with, that they'd be congruent, all right? And we got to prove the two triangles congruent. So shut me off right now and write the proof and see how well you do. Okay, we're back. The first thing we should do is get our given on. So we got a given. Okay, and I've got those two pieces. Now, in this one, I'm not writing them all at the same time. I'm writing the given and everything as single steps. And you could do this. Okay, you don't have to. There's a lot of choices when you do this. So now that we've got the given down, let's look at what we've got. So I've got MA is congruent to TA because the definition of midpoint. So I'm going to go MA is congruent to TA because the definition of midpoint. And I'm going to mark that MA congruent to TA. And I also know that SA is congruent to RA, and I'm going to find those for that same reason, SA congruent to RA. Okay. My next thing is to talk about the triangle's angles. So I'm really going to prove these two triangles congruent because of side angle side. So I've got the angles, vertical angle theorem, and angle SAM and angle RAT, because those are my vertical angles. And I will make sure you see those. And I got SAM, SAM, RAT, RAT, be our angles that correspond in order. And I've got the two triangles congruent because of side angle side congruence. Now our next thing is to prove that I have segment MS parallel to segment TR. In order for me to prove that those two segments are parallel, I've got to use one of the theorems we've had in the past, a converse theorem. Okay, because now keep in mind, since these two triangles are congruent, I now know that corresponding parts of congruent triangles are congruent, which means that S is congruent to R and M is congruent to T. Now I can use either one of those, okay, and use them as alternate interior angles, okay, and once I know alternate interior angles, I'm going to use M and T here. Once I know alternate interior angles are congruent, then the lines are parallel is a converse of alternate interior angles. Okay, so if I know that those are congruent, those two angles, M and T, I can prove the lines are parallel by the converse theorem. So now M and T, angle M and angle T, are congruent because they're corresponding parts of congruent triangles, and they're congruent, CP, CTC. And my final step is to show that the two segments are parallel because of the converse of alternate interior angles theorem. All right, so we have this particular proof completed, and we have one. So now our next proof here for our notes and our last one for today, we're looking at this proof, and I got segment MP bisects segment LMN, and segment LM is congruent to segment NM. Okay, so mark up your diagram here. We know that for sure. We know we can say something about this. I'm dotting it because I have to talk about it before I can say that it's true. And then I know I can say this, okay, to prove my two triangles congruent. Now, I'm going to show you the steps, or at least the jumbled version of the steps that we have. And I want you to place them in your proof after you turn me off, and then turn me back on and see how well you do. Okay, so turn me off at this time. Okay, welcome back. First thing you should be doing is putting in your given. So we have our given, and we got that going on. We kind of pre-marked our stuff, so I know by definition of angle bisector, I know NMP and LMP will be congruent. So angle NMP and angle LNP will be congruent because of the definition of angle bisector. I also know that by reflexive property, I have PM congruent to PM, or MP congruent to MP, because of reflexive property of congruence. Okay, now, right now, I have these fully marked and in, and I have a side angle side relationship with the two triangles being congruent. Now I've got the triangles congruent by side angle side congruence. What you got to know right now is when I talk about corresponding parts of congruent triangles are congruent, I know that parts of congruent triangles are congruent themselves. So I can talk about LP being congruent to NP, okay, because of CPCTC. So we're going to say, hey, you know, segment LP is congruent to segment NP because the corresponding parts are congruent triangles. And because of that, I can now talk about, by definition of congruence, that the length LP, the length between L and P, is equal to the length between N and P, and that's by definition of congruence. Okay, so that's our final bit with that. And we have our triangles proven and our pieces taken care of. Now, our summary, objective. Students will be able to use triangle congruence in corresponding parts of triangles to prove that parts of two triangles are congruent. Please write a couple sentences about something that you learned today about the learning objective, then rate yourself from 0 to 4. But please, 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 please keep in mind, this is day 4 and section 4, and we should be able to check off quite a few things from our chapter 4 formal scale. So start checking things off as you're looking it over and see where you're at with the things you already know and the things you've yet to know. If you have any concerns or questions, please locate your local geometry teacher and have a chat with them. Have yourself a wonderful day, and we'll see you soon.